Hello guys, and welcome to this video where we see how we can implement WebSockets for real-time applications in our NestJs backend. So basically we're going to create a WebSocket gateway for a chatting app as an example and see how we can actually make that work. First of all, I've just created a normal NestJs application with the CLI. So we have an application listening on port 3000, and this is just the basic setup. Now the first step here is to install two different npm packages, NestJs/WebSockets and NestJs/platform-socket.io, which uses socket.io, which is a very popular WebSockets library behind the scenes. So let's go ahead and install those. And now let's go ahead and create a new module and let's call it chat. So nest generate module chat. And in this new folder chat, we're going to go ahead and create a new file. Let's call it chat gateway.ts. And now here we're going to create our WebSockets gateway or our WebSockets server. This is the same thing. So let's go ahead and do that. I'm gonna call it chat gateway. Of course, you can call it anything you want. You can call it WebSockets gateway if you want. Now to make this an actual WebSockets gateway, we need to decorate it with WebSocket gateway, which is from NestJs/WebSockets. With this in place, we can now have real-time communication between this server or this NestJs application and different clients that connect to it. Now by default, this WebSocket server is running on port 3000 because if you take a look here, by default our app is running on port 3000. But of course we can override this. So if you take a look here, we can pass in an optional port number. So we could say 3002 for example. And on top of that, we can also pass another parameter here, which is some configurations. So we can specify a namespace, we can specify the course policy and so on, but for now I'm gonna keep it empty. And by the way, you can think of a WebSocket gateway just like providers. It can be injected as a dependency and it can also inject dependencies. And just like providers, it needs to be registered so that it can be used. So this chat gateway should be registered in our chat module, for example, in the providers array. And of course, chat module, since we created this module with the CLI, it has been added to our imports in app module. So now if you go ahead and run this server, we can see we got chat module dependencies initialized. Now the next step is actually listening to messages. Normally in socket.io, we're used to seeing something like io.on and then we have the event name, for example, connection. We're also used to seeing socket.on and then we get the event that we're listening to and then the message. So how can we actually do that in NestJs? Well, it's pretty simple. All we have to do is use a decorator, add subscribe message, and then we need to specify the event or the pattern that we're going to be listening to. Subscribe message is from NestJs/WebSockets. And then here we need to create a handler for that message. I'm going to call it handle new message. Of course, we can call it anything you want. And to get the message from the payload, what we can do is also use a decorator, message body, and then we can get the message. It can be of any type. So it could be an object, it could be a string, a number, anything you want. Let's go ahead and just log this for now and run our server again. And now if you take a look at our logs, we can see chat gateway subscribed to the new message. So this is our new event. We are now subscribed to this event. And if any client sends a message on that event, new message, to our WebSocket gateway, we are actually going to handle it here and just log it for now. So let's go ahead and use Postman to test this out. So to test this in Postman, all we have to do is click on new and then we need to select socket.io. Be careful, not WebSocket, but socket.io. And now we need to enter the URL for our WebSocket gateway. Of course, we're running on localhost. And then for the port, if you remember, we have specified 3002 for our WebSocket gateway. We said that by default it listens to the port that our app is listening on, so 3000. But we can override this value just like we did here. So now it's port 3002. If you go ahead and hit on connect, as you can see, connected to localhost, everything is fine. And we are now able to actually send messages on some event name. Now if you take a look here, we're just listening on new message as our event name. So let's go ahead and specify new message. And then here in compose message, we need to specify the message that we are going to send. We said it could be a number, it could be an object, or it could just be some string. For now, I'm just going to say hello. And now if we hit on send, as you can see, new message has been sent and it says hello. Now if we go back to our backend, we can see that we have actually logged hello. So we have successfully subscribed to the new message event, and we are actually capturing the data that is being sent by the clients. And of course here you need to think of Postman as a client, so it is a user. It could be a browser, it could be a mobile app, it could be an Angular app, React app, any client that is trying to communicate with our WebSocket gateway or our WebSocket server. So now we have seen how we can actually implement socket.on to listen to events by using subscribe message. Now let's see how we can actually emit messages by using socket.emit, and then we also need to specify an event and then the payload. So how can we actually send a message back to our client here? Well, instead of using message body on its own, we could actually go with another approach. We could say client or socket, which is of type socket. It's not shown here, but it's actually imported from socket.io. And if you take a look here, this is the normal socket that we usually have in socket.io. It has an ID, it has a handshake, some data, and so on. And now, of course, we also need to specify the message, which could be of type any. And now, with this client here, we can actually now say client dot, and we can see all of those different properties and methods. So we can actually say emit, and we can specify an event. So we could call this reply, for example. And then here we could say this is a reply. Now if we save, and if we go back to Postman, now if we connect again, because of course every single time we restart our WebSocket gateway, we have to actually connect again. Now if we hit send on new message, as you can see we have sent a message, and as you can see here we have logged this, but we did not receive a reply here. And that's because we're not actually listening on this event. So on the Postman side or on the client side, we need to add an event in the events tab. It needs to be reply, and then we can set it to listen. And now if we go back to actually sending events, so send, as you can see we sent a message hello, and then once we sent a message hello, we are actually replying back to the client. We are emitting something back on the reply event, which you can see here. So every single time we send a message now, we are also getting a reply back. So as you can see, we are able to listen or subscribe to events and receive messages, and we are also able to actually respond back to the client that was behind this message. But sometimes we don't just want to reply to one client. Instead, we want to broadcast a message to all the different connected clients. So how can we actually do that? Usually we do that using io.emit. This is used to broadcast a message to all the connected clients, unlike socket.emit, which just sends a message to one single client. How can we do that in NestJs? Well, it's pretty simple. All we have to do is use WebSocket server as a decorator, and then now we have access to the actual WebSocket server instance, which is of type server, which is from socket.io. And now what we could do is just say this.server. And then we can see we have a lot of properties and methods. We can say emit, and then here we can say reply as well, and then broadcasting. Now if I run this again, if we open Postman and hit connect again and then send, we can see that we sent a message and then we got two replies. The first one is saying this is a reply, and then broadcasting. Now we can't really tell the difference because we're just listening on one client. So let's go ahead and actually create more clients. So this is another client, another user, and this is a third user now. We need to connect all of those users. So let's connect and let's connect. And let's also listen to the reply event on every of these new clients. So let's listen to these. So what we could do is in message here, say new message. And then let's send something. Hello, I am client 2. If we hit on send, as you can see, we have sent a message. Hello, I am client 2. We received two replies. This is a reply, and then broadcasting. If you take a look at a third client, we can only see broadcasting. So we didn't get the first reply, which is this is a reply. We only got the broadcasted reply. And this is because, just like we said, whenever we emit a message on the server instance, we are actually broadcasting it or broadcasting this message to all the different connected clients. However, when we say client.emit, we're just emitting this message to this single client that was behind this original message that was captured here. So this is the difference between client.emit and server.emit. Let's test this out again. So now if I try to send a new message from client 1, this is client 1. If I hit on send, we got 2 replies. This is a reply and then broadcasting. However, here we just got broadcasting, and on client 3 we just got broadcasting. Now usually in socket.io, in the backend side, we have something like this, io.on connection. So our server is always listening on the connection event to track if we have new clients connecting, and then we get the new socket instance so we can log the ID of the new socket connected or do something, handle it in some way. And then we also listen on the disconnect event of that socket. So whenever the client with that socket disconnects, we can also do some handling here, some cleanup or anything else. So let's see how we can actually handle that in NestJs, how we can handle the connection event, okay, whenever a client connects to our server or whenever a client disconnects from our server. What we could do here is we could implement 2 different interfaces on gateway connection and on gateway disconnect. Those are 2 different interfaces. If you take a look, we have to implement handle connection for gateway connection and then handle disconnect for on gateway disconnect. So let's do that. Handle connection, and this takes a client of type socket. Again, you can call it socket, you can call it anything you want. I'm just gonna call it client. And this is the same as saying io.onConnection. So here, for example, what we could do is we could just, let's say you wanna log a new user connected, and then here we could say client.id, which is going to be the socket ID. And for the disconnect, let's do the same thing. So handle disconnect. It also takes a client of type socket, and we could just say user disconnected, and we're just gonna show the ID. Now if we run our backend again and in Postman we connect again, if you take a look here, we got new user connected because we are actually handling a new connection, a new socket. And then if we go ahead and disconnect, as you can see, we got user disconnected, and this is of course the same socket ID. And of course, if we added new users here, connect, a second one, a third one, as you can see, we are getting every connection here. So this is just the same way of actually having this, but in NestJs. So I added some logic here to make our chatting app a bit more interesting. So every single time a new connection or a new clients connect to our WebSocket gateway, we are going to emit a message on the server. So we are going to broadcast it to every single connected client listening to user joined, okay? And then we're gonna just say user joined the chat, and then we're gonna show which new user joined. So to make it clearer, we could say new user joined the chat. And every single time a client disconnects from our WebSocket gateway, we're going to emit or broadcast a message to all the clients on user left, okay, saying user left the chat, and then we're just gonna print this client ID. And every single time we get a new message, okay, so we are subscribed to new message, this is the event name, and we receive a message, we're just simply going to broadcast it to all the connected clients, because as you know, every single time you're in a group chat, if you send a message, every client in this group chat is going to actually see that message. So we need to make sure to broadcast it to all the participants. So this is what this is doing. So I asked ChatGPT to actually create a simple user interface and to actually connect to our WebSockets gateway. So as you can see here, localhost port 3002. And I gave it the different events that it should be actually listening to, such as message, user joined, and user left. So as you can see, we have socket.on user joined. It adds a message to the screen saying joined. So it is showing the different activities on the client screen. Okay, everything is here. And I also asked ChatGPT that whenever a new client connects, I want to print you have joined the chat so that this client can see that in front of his screen. And that's pretty much it. That's a simple UI. Let's go ahead and copy this and try to run it. So as you can see here, we got type your message, we got a button saying send, but we cannot see the you have joined the chat message. So let's go ahead to our console, and as you can see, we have been blocked by course policy. So fixing this is simple. We just have to specify our course policy. So just like we said before, we can set this up here, we can configure it here. So what we could do is just allow everyone for the sake of this, but here usually you would have the URL of your front end or any client that is allowed to actually access your WebSocket gateway. And as you can see here, we now got new user connected. If you go back here, we can see we got you have joined the chat, and we got the message saying that we actually have joined this chat. Now, normally we don't really need to show the same user that they joined the chat again, since we just have you have joined the chat here. So what we could do is actually broadcast this message to everyone except the user that actually joined. Let me just explain what I just said. Let's say we joined as another client and then as a third client. So these are three different users now. You can see here we got new user joined, which ends with AAAD, which is the second client. And then we got a third user, which ends with AAAF that just joined, which is the third client, the third browser, the third user. It's a separate user. As you can see, this third user also got a message saying new user joined, which shows its own ID. So what we could do is, in our backend, instead of actually saying server.emit user joined, because what this does is it actually sends this message to everyone, including the client that actually connected. So what we could do instead is we could say client.broadcast. So if you take a look here, the event data will only be broadcast to every sockets but the sender. So the sender is not going to receive that message. That way the sender or the socket that just joined is not going to see its own message that it just joined. So to do that, we could say client.broadcast.emit, and then here we can specify this, and we can remove this.server.emit. Now if we save and go back here, if we open another client, as you can see we just got you have joined the chat. So I cleaned things up to make it clear now, and I joined as a new client on this browser. So it just said you have joined the chat. We can go ahead and say hello, for example. We can send a message, and we got it on the screen. This is the socket ID. And now if we try to join as another client, as a different client, we got you have joined the chat on our own screen. We no longer get that a new user joined with user ID again, because instead of using server.emit, which sends a message to everyone including the sender, instead we use client.broadcast.emit, which sends a message to everyone except the sender, which is why now we don't see that message. I think it's clear that way. However, on the first screen, or the first client can see that a new user just joined, which ends with AAH. And now I am client 2. Let's just send this. If we hit send, the first client can successfully see this from the user AAH, which is the user that just joined. Let's say a third user joined. As we can see, client 1 can see that a new user yet again joined. User 2 as well can see that a new user joined. Here, client 3 only sees you have joined the chat. Hello, I am client 3. If they hit send, we can see that AAAJ has sent a message on every client screen. And if AAAJ, which is client 3, leaves the chat room, as you can see, we actually got user left the chat. And this is because, again, on our WebSocket gateway, we are handling the disconnect by emitting or broadcasting a message on the server to all of our clients, connected clients, with the user left event saying user left the chat, which of course on the client side we are listening on. So socket.on user left, we add a message, and so on. So as you can see, everything is working correctly. Our chatting app looks nice. We are listening to different events. It's working in real time, and it's very easy to implement. Like, this is the back end side. It's very simple. Also, if you notice, this time the data that I emitted was not a string, it was actually an object with a key of message and then the value, which is the string. Of course, you can send anything here. I could have sent a new user has joined right away, and in that case, on my client side, I would actually read the message right away without actually needing to take the message key. So without actually having to say data.message, I could have said data, in case I sent it as a string instead of an object with a key value pair. Now, of course, everything that works with socket.io works normally here. So for example, if you want to send a message to a certain room, if you want to join a room as a client and so on, all of that can be implemented, but we're not going to cover it. We just wanted to cover the basics of implementing a WebSocket gateway in NestJs, which is what we just did. Let's go ahead and see a quick recap. So to implement real-time in our application using WebSockets, we would need to create a WebSocket gateway. But to do that in NestJs, we first need to download two different packages, NestJs/WebSockets and NestJs platform socket.io. Once we've done that, we can create a class and decorate it with the WebSocket gateway decorator. And then we can either keep the default port or we can override the port. And we can also pass in some different configurations, such as a namespace, course, and so on. Once this is done, to be able to use that gateway, we have to register it in the providers array somewhere in our application, because it is similar to a provider. It can inject dependencies, it can be injected as a dependency, and so on. Now, to be able to listen to messages, we have to use the subscribe message decorator, which is similar to socket.on, and then we need to specify the event name. And then here we should have a handler, which can have any name. And then to extract the message from the payload, we could use message body as decorator. And the message could be of any type, string, number, object, and so on. Now, in case you want to broadcast a message to every single connected client to your WebSocket gateway, we could use the server instance of our WebSocket server. So to do that, we could use WebSocket server decorator to get access to that server. And then here we can use emit on that instance to actually broadcast a message to all the clients that are connected on a specific event name. Now, in case you wanted to use the client, you could have just specified client here of type socket and then the message. We also saw that. And this is used to emit a message to the sender. Now, in case you want to detect connections and disconnections, we could implement the onGateway connection and onGateway disconnect interfaces, which will provide us with handle connection and handle disconnect methods, which take an actual socket instance or the client instance. And then here we can actually do some logic, such as logging the ID and so on. This is all from our back-end side. Now, from our front-end side, we need to connect to our WebSocket. So if we go back to the code that ChatGPT generated, as you can see, we are connecting to our socket server, so localhost 3002, which is the port here. And then now we can actually start listening to messages, so socket.onMessage, which is the event that we are emitting here every single time we get a new message. We broadcast it to all the clients. That way they can actually build their user interface to see those different messages. We are also emitting a user joined and a user left messages in case a user has left or disconnected or a user has joined. We said that client.broadcast.emit is almost the same as server.emit. The only difference between those two is whenever we use client.broadcast.emit, we are actually emitting or broadcasting a message to every single client except the sender, so except this client instance that made that event or that caused that event. And on the client side, we can also emit an event. So for example, if you take a look here, whenever we are actually pressing the button, whenever we are clicking it, we are emitting a message on that socket with the event name new message, which we are listening to in our backend or our WebSocket gateway here in our backend side to get that message and then emit it back to all the clients to show it on their screen. This is pretty much it. If this video was helpful, please make sure to leave a like, subscribe, and let me know what you want to see next. Thank you so much and see you next time.